This time we have a new challenge. We have a Fox Tango 790 for the 70 cm band, and we have an amplifier with a preamplifier in it. It has a coaxial relay in it, because here is the antenna going, and we have an input and an output, but on the FT790 we have only output and input, because there's also a relay in it. So what we need is a relay and we need something to control that relay. Seeing the prices of many coaxial relays, I thought, let's make one of my own. I had a very small relay, but it's intended for HF, and it ends up at 900 MHz 10 watts, so that's a lot. And the idea is to have some coaxial cables, just cut them, solder them to a small PCB. Already seen a lot of difference in coax cable. This one has copper shielding, but it is very open. And this is another material, likely also copper, but it is more rigid. To me this looks better, but in fact I need 3 cables to connect. With this specific stripline relay, these contacts must be soldered to the ground plane, and the others, hard to see, to the coax cable. So I prepared the coax cables, and I will now solder it all together. Especially when you solder the shielding, you must be aware that when the insulation starts to get glazy, you don't move it, because it can result in a short circuit. It's always difficult to define in which order you solder it. I now soldered first the coax cables, and then hopefully I can have enough space to solder the other points. And over the DC coil I now solder an 1N 4007, and then in fact it is ready to test. I connected the relay one side to a dummy load and the other side to the input and output of the NWT 6000, and then we can see the result. First I took just some cable before I cut it in 2 pieces, and that's this result. And the frequency span is from 50 MHz till 1500 MHz. And when we choose for wobble, then we see that this is the now connected relay, and it's not too bad. The relay is specified till 900 MHz, and we see that is even on 1500 MHz still acceptable. This is the straight through the relay. And now we do the same with to see what the damping is. Therefore I only had to change those 2 connectors, and then we see the result. And here we have about minus 70 dB, and it's going up here 1000 MHz, and then it's even more than 40 dB down, so to the unwanted port. So in fact that's very good, and when we go to higher frequencies it is even still better, to 30 dB. What we see now is the same configuration with the straightforward. And now we put the 12 volt on the relay. We hear them clicking. And then we see some difference between one port and the other port, but it's still till 1000 megahertz or even 1100 megahertz. It's still more than 14 dB down. So everything in one graph, straightforward. The lines are completely over each other. Straightforward, port 1 to 3 and 1 to 2. And here we see some difference in the damping between the ports that should be as high as possible be damped. And I need a small circuit as HF Fox that can be used to switch the relay. A final word about the relay I used. I had it laying around for a very long time and it is obsolete, and even the replacement is now obsolete. So you have really to search on the internet for such relays, RF, HF relays, and they can be bought under 10 euros, and you come up to this kind of companies, RS, Farnell, you name them. Possibilities how to control this relay will be discussed in another issue on my channel. So stay tuned. See you.